Hi there! This is the wrap-up of my series of the videos on the Ovon XTM1041, and I'm sure you are as relieved as I am. This video became necessary because the previous one on the performance overran a bit, mainly because of issues with temperature measurements. Let's start with this little utility coded in Python, which can be downloaded from my GitHub page, link in the description. You saw it already briefly in the previous video. It works on Linux and Windows. The main purpose of this software is recording and nothing else. I thought of adding remote control, graphing and what else, but in the end I decided against it. There's a PC utility that Ovon provides for those who want remote control from a PC, although that leaves a lot to be desired, as you will see. You enter the port the Ovon is connected to. On this machine it's COM6, and select Connect. If the XTM1041 is connected, it will show the device identification in the line below. The number on the left is simply counting the elapsed seconds. I found this useful because it allows a quick check that everything is still running and the display is updated. In this line you see range. Currently it's 5 volt auto range, the function, volt, and the measured value. In dual mode you would see the second function and its value on the right. The measured value uses the unformatted direct measurements available from the SCPI. This has higher resolution but is also a bit noisier. I made my own formatting that will display this in engineering format. So while the smooth XTM1041 display, for example, shows mostly just 0.000 at the moment, you can see that the actual value fluctuates in the 100 microvolt range. If I select volts AC and put some AC voltage on, you can see the results are echoed in my utility as well. Selecting dual and frequency enables the second display. There are two recording modes. The first one is auto. You select the periodicity, how often you want the values to be recorded, between once every second to once every hour. Then you just hit the auto-rec button and the file name preceded by arec appears. The number on the left shows how many entries are in the recording file, and the number above shows the number of seconds the recording is on already. To stop recording, just hit auto-rec again. The other recording mode is manual. When you hit manrec, a recording file is generated just like in auto mode, but the name is preceded by mrec, and values are only recorded every time you click record this or hit the spacebar. This mode is actually quite useful if you do a series of measurements where you need a lot of time to adjust values or change setup in between values. It avoids filling the recording file with repetitive or unstable values. The recording file format is CSV and can be opened and processed directly in Excel or LibreOffice Calc. This gives you a lot more options to graph things or do all kinds of statistical analysis than a utility could ever do. As a bonus, my little utility makes PT100 usable on the XTM1041. For that, you run the XTM1041 in res mode and connect the 3-wire PT100 probe using the two ends that are connected together. I use red plugs for those. This shows you the wire resistance, which is 0.26 ohms as measured by the XTM1041. Now press rel to null it and replace one of the red plugs with a black one. The meter now shows the correct resistance of the probe in ohm, and the utility shows of course the same resistance value. If you now press the PT100 button, the utility takes the resistance and calculates the equivalent temperature for PT100 probes. Note that the temperature must be above 0 degrees Celsius for this to work. The calculated temperature is shown in the place for a second measurement. Of course, this only happens on the utility. The actual meter continues to show only the resistance in ohm. Last and least, you can change the PT100 temperature unit to Fahrenheit or Kelvin if you like. After my simplistic and tiny Python utility, let's see the alternative for use for the XTM1041 remote interface, namely the DMM Easy Control PC software, which you can download from Ovon. I have to warn you that if your machine has not already been used for LabVIEW and such things, installing this takes a lot of time because you will need the NI Visa driver, which turns out to be a whole suite of software, all completely irrelevant for a simple serial port. Yet, to get the simple DMM Easy Control running, you need it, and the NI Visa suite in turn needs the runtime of Microsoft Visual Studio installed, and some other stuff. Anyway, the whole installation thing is very frustrating and time consuming. Well, once you manage to jump all these hurdles, you can run DMM Easy Control. This is version 1.4.4 by the way, which obviously is also used to control the more expensive Ovon bench meters because there are functions here that the XTM1041 doesn't have, like filter, input Z and limits. Anyway, clicking connect starts the NI Visa machinery in the background, so it's not surprising that nothing happens for a while. The only connection method that works is via COM, which offers asynchronous serial or ASRL 3 or 6, which turns out to be simply COM3 or 6. I have to admit that they did a very good job in making the display look nice and very close to the actual display of the XTM1041. The only problem, the remote control part doesn't really work all that well. According to the program, we are now in DC volts, but in fact we are still in resistance mode, but lost rel. Switching to AC volts is also not working. In frustration, I used local mode and turned the multimeter to DC volts, which is recognized by the software, although the function is still wrong as DCI. I'm not boring you with more stuff that doesn't work, but continuity at last did change the meter. It is funny because I have not used this program for some time and I knew it was full of glitches, but I don't remember it being quite that bad. I put some AC into the meter and set it locally to AC. That enabled the remote selection of dual and frequency, which worked for a change. I was curious to see how they display this. Again, this looks really good, no question about it. Sadly, turning the dual display off doesn't. Maybe another glitch, or because there's no exit button. A bit of an oversight. Next, I want to see the averages and clicked math, which is what this is called on the meter itself, but in the PC program it selects dBm. Nice, but not what I was after, which is apparently called statistics on the PC. But when I clicked math again to turn the dBm off, I got this. Fatal application exit. Oh dear. But I did want to show the statistics display, and so after a restart of the program and reconnect, there you go. I think these are actually calculated by the meter and transmitted over the SCPI, although it would be far easier for the PC software to calculate them from the incoming measurements and display them all the time. An approach they did with the recording. As I mentioned before, there is no way to remotely access recordings done locally on the XTM1041, so the PC software does the same as my utility, simply recording the real-time data coming in from the SCPI. This is done using record. It asks specifically for an Excel file for saving, extension XLS, which is the really old Excel format. Next, you can do automatic or manual and specify the number of points and the interval. I picked 40 points and 2 seconds. But I did not read this too carefully and I missed that the interval is in milliseconds. I should have typed 2000 for 2 seconds, but what I specified was 2 milliseconds. Expecting a recording time of 80 seconds, I was surprised that the end of recording popped up after roughly 18 seconds already. Anyway, that gives us a clear indication that the maximum speed is about 1 recording every 500 milliseconds. Let's have a look at the result. I'm using Notepad first because I want to see the actual content. I somehow doubt that they created it in a Microsoft proprietary binary format. And sure enough, despite the extension, it's plain text. in a pretty useless format, not even CSV or comma-separated values. Let's see what Excel makes out of this when I double-click the recording file. Oh yes, it complains bitterly about the corrupted and unsafe file and that we should not open it. That is normally good advice, but in this case let's open it anyway, since we already know it's just plain text and does not contain malicious stuff. Excel does its best to make sense of it, and the format is sort of usable. The timestamp formatting is so weird that it will take quite a complicated set of Excel functions to format this into proper date time. The chosen format to have separate columns for every possible function wastes a lot of space. I can't think of a case where it would make sense to switch measurement function in the middle of a recording, but anyway, that's what they catered for. Now it turns out there are more people on YouTube reviewing the O1 XTM1041, and this fellow, Pallav Agarwal, I probably pronounced his name wrongly, sorry, made one showing with the DMM Easy Control, and it works much better. I put a link to his video here. You should watch it because he goes into some detail on SCPI as well, besides showing how nice his XTM1041 works with that PC software. Seeing this work so nicely confirmed my suspicion that my XTM1041 also used to work better with this PC software before, and the only thing that happened since is that I upgraded to the new firmware shown in my last video. Has O1 broken something on the SCPI? To find out, I fire up my little test program that I use to explore the O1. It is very simple and just sends a text string on the serial port to the XTM1041 and then waits for up to 1 second for a response. So for example, star IDN question mark should return the ID string and firmware, and it does. Mes show question mark returns the measurement as formatted on the display, while mes1 question mark returns it in unformatted higher resolution. Anyway, so far so good. Let's switch the meter from DC mode to AC mode, which is something the DMM Easy Control can't do anymore. The command is conf volt AC auto. It works, but the meter returns this weird OK with /n or new line control characters. That's new. It did not do that before. According to SCPI, only commands that end in a question mark should return anything. Switching to DC current 50 milliamp range, conf cur DC 50 exponent minus 3. It does it, but the same thing. The command works, but the firmware sends these crazy OKs. If we send a command that should cause a response, like what function are we in, it behaves correctly. In fact, you can even send total nonsense like hello world and you get 3 OKs. I have sent a message to O1 in the hope they clarify this and correct the firmware. So far, no response. So you may want to hold off updating the firmware that is dated 25th of May 2021. I interrupt this video for some breaking news. Further investigation show that the new firmware responds correctly to SCPI. Normally. It turns out that using the XTM1041 with the DMM Easy Control software can mess it up to enter into a mode where it responds with OK to everything. One way to trigger the problem is to enable statistics on the DMM Easy Control, but there might be others as well. Once in that messed up state, you get the OK response on SCPI, and the only way to get back to normal is to power cycle the XTM1041. Now, it's still possible that this is a feature of the new firmware, so it would be nice if viewers out there with the XTM1041 could try triggering the bug and report. This issue brings us to the SCPI commands themselves. You have just seen how easy it is to command a multimeter using SCPI, and the commands are pretty similar whether it's an O1 or an Agilent multimeter or a Rigel scope. There are some standards, one of which the O1 obviously just violated with their OK thing, and then there are differences and dialects in the way certain commands are implemented. That is why the commands are only similar, not identical. The SCPI of the XTM1041 is not documented, but the XTM2041 is, so I use that and a little utility you just saw to find out what works and what doesn't. This is all documented in this table, which you can download from my GitHub page, link in the description. One note, the SCPI commands can usually be abbreviated. For example, you can type configure or conf. I am lazy, so I often show only the abbreviated command. The most important commands are mes for returning measurements and a list of conf commands to switch the meter into the different functions. I leave it to you to study the table in detail if you are interested. Here I just want to highlight some of the more interesting bits. I mentioned already that the mes :show ? Returns the rounded and formatted measurement, which includes the unit. There are some other commands that return units, and you need to be aware that the XTM1041 uses some strange encoding for special characters like ohms or micro, which are not UTF-8, so some hand conversion is needed to handle these. As you have seen earlier, you specify the range using strings like 50 exponent -3 for 50 millivolts. This table shows the XTM1041 implements standard SCPI shortcuts like min, def and max, which you can use as alternatives to get the lowest, highest or default range. So to switch to 50 millivolts, I could have also sent conf volt DC min. You already know about the 3-second pause. Every 600 seconds, the XTM1041 needs to update the cold junction temperature while you are in temp mode and KITS 90 is selected. During that time, it does not respond to SCPI commands, but it queues them and you get the response all in one chunk after the 3 seconds. Not really bugs, probably, but things that should work, and maybe I just have not figured out the right sequence for the XTM1041. Just like for dB, we should be able to set and get the selected reference value for dBm, but the meter does not respond. And the value returned by calc null offs should be the value used by rel, but the value is mostly 0.0 regardless of the rel value, and if it's not, it does not make much sense to me. To be fair, I did not spend too much time on it either. The last bug so far concerns the frequency value you can select using dual function as a secondary display in AC modes. It is shown correctly on the display, but if you are in one of the millivolt, milliamp or microamp ranges, it is incorrectly scaled on the SCPI. For example, in the AC 500 millivolt range, 50 Hz is returned as 0.05 Hz. My recording utility program you saw earlier corrects this automatically. And then there's this little quirk. If the beep function is on, the status return is no instead of on. Last not least, remember that my meter contained those cheap 20mm fuses on the analog board instead of proper ones. Well, I said then that I was going to fix it, and after I got the proper long fuses with the right ratings, this is what I've done. When I looked at the board, I noticed there were additional holes in the PCB which allowed for larger fuses. Naively, I thought all I had to do was desolder the holders and move them to the end positions. This is what I did, and here's the state after I resoldered the first holder back using the outer position. What I did not realize is that the end positions are then too far apart, at least when using the original holders, which also don't fit in the holes on the right. It became necessary to bend one pin horizontal and use an additional short piece of thick copper wire through the hole to properly connect upper and lower traces of the PCB. Well, the sockets are all back in and have solid solder connections. This was way more trouble than I expected. The new fuses are in. My only issue is that it doesn't look as pretty as it could have if I had used different and better fitting fuse holders, but I simply could not find any better ones than the ones that were already on board. Despite the new fuses, I am under no illusion that if you would use this meter in a Cat3 or Cat4 environment to measure mains volts and accidentally leaving the meter in amps, there is not much that would remain from fuses, fuse holders, PCB and the meter itself. So to put it simply, don't do it. Stay in Cat1 work, bench territory, where this meter belongs anyway. My final verdict? The XTM1041 has more quirks than I expected, and the jury is still out on the firmware patch. I hope they are going to send another one. If you are on the lookout for your first multimeter, definitely get a good handheld instead, because they are much more versatile. And if you have a handheld already and are looking for your first bench multimeter, and form factor or size is not that important, I would suggest in spending a little bit more and get something better, or try to get a decent used Fluke, Agilent or Keithley or similar. I still like the XTM1041 and I don't regret buying it. It is reasonably accurate, works reasonably well apart from capacitance, and is now an integral part of my bench setup, taking no space and always on, ready for a quick measurement or continuity check with its large and clutter-free display, or running a quick recording without having to fire up the big guns like the Agilent 3441A or the Solartron 7150, or clutter the desk with handhelds which waste batteries when left on for long periods. To be honest, that convenience factor makes the XTM1041 so attractive for me, because I have alternative multimeters to use when I need more accuracy or more ruggedness or portability or protection. If there are major developments on the firmware, I may add a quick video to keep you informed, so don't forget to subscribe if you not have already, and maybe consider becoming a Patreon, link in the description. As Patreon you get early access to videos, blogs and other exclusive content. Thanks for watching.